So welcome to section 2 of the InfoDrainage training course. If you've just completed section 1, then your model should look like this and you can continue working immediately from here. If you are running this section in isolation and you haven't completed exercise 1, then you can load in this model to look exactly like this by going to File and Open and looking in the Answers directory of the InfoDrainage introductory training, clicking on exercise 1, and that should load it up from there. But as I say, it starts immediately after section 1. Now in this section, we are going to be looking at the topic of model build. So we are building our urban drainage system. And I think as you start along this process of learning how to build urban drainage models, it's important to keep in the front of your mind what we're trying to achieve here. Basically, we're looking at what exists in reality, or what we hope will exist in reality once we've built it, and we're trying to produce a representation of that in a computer model. So there are assumptions that we're going to have to make, there are estimations that we're going to have to make, but at the front of our mind, we're trying to produce the best replication of reality that we can using this computer model. And when we come to the model build section, it's basically divided into what I call 4 building blocks, 4 separate sections. And these are listed over here in the toolbox on the right of the screen. So we've got inflows, junctions, stormwater controls, and connections. So our junctions include manholes, simple junctions, standard manholes. So these are what we might consider to be points in space. Then there's the connections. So these are things which connect up the manholes. So the most obvious example would be a series of manholes connected together by a series of pipes. There are other things like lags flow and no delays, which I'll explain as we go through, but that's the most simple example would be manholes connected by pipes. We can then put into that our various stormwater controls. So things that you're familiar with, like ponds, tanks, that sort of stuff. Maybe others that you aren't so familiar with. These would be SuDS features, Sustainable Urban Drainage Systems. Some people call them BMPs, Best Management Practice. Others call them LIDs, Low Impact Development. But whatever we call them, our job is to try and represent them in these InfoDrainage models. So we put those in as well. The 4th building block is the inflows. Now these are going to be the contributions to our model. And today, in this course, we're focusing mainly on stormwater inputs. So this is going to determine how much rainfall gets into our system. If we were dealing with a foul, what some people call a sanitary system, then we would be looking at the population flows, the industrial discharges. They are simple in comparison with stormwater flows. So we're going to concentrate on the stormwater flows throughout this course. Okay, but those are basically the 4 building blocks. Now, if you're following along with the notes, we're right at the start of section 2, the model build section. And the first thing to do is from the plan view, switch on the snap, because we're going to be snapping to this background CAD data that we loaded in section 1. So that's going to be our starting point and our guide to creating this model. The way that we create something is we pick it from the toolbox. So I'm going to start by selecting a manhole. And all you do is you can zoom in now or zoom in as you go along, but you click it, left click on it and drag it, and then as you get close to the digitized point, it should snap to it like that, as long as we've got the snap turned on in the plan view. And just keep going like that. So you've got the manhole selected, just click and snap, click, it should snap like that, click and it should snap like that. Now if we put one in the wrong place, like that, what we then need to do is go to the select tool, and I probably want to zoom in at this stage so I get it exactly the right place, but pick on the select tool, click it, and you'll see that it snaps there. It hasn't quite snapped, so I can go right in and get it exactly right. Okay, and then we just carry on from there. So back to the manholes, drag and snap and drag and snap like that. Along we go. And as I say, you can zoom in and out whilst you're going along. Let's say, for example, we put in one that we don't intend to there. Now, what you can see is happening is over in the tree view on the left-hand side, these are now being listed under the junction. And from here, we could rename them. So just right click on it, you get the opportunity to rename it. We can delete it from here. We can basically do what we like from here. We can decide whether or not we want them displayed just by clicking on that tick box there. Okay, so let's firstly deal with this one that we created, which we didn't mean to. So as I said, we could delete it from here, or we can just go back to the select tool, highlight it, and then just press delete on your keypad and it goes away there. Now, one top tip that will exist throughout this training course is whenever you're creating something, like you're creating a manhole, once you've finished doing your creation, it's always good practice to go back to the select tool immediately. Just press on the select tool. Otherwise, whatever you do, if you click on something, it would try and create another manhole or another item that you just listed there. So it's always good practice. Once you stop creating things, go to the select tool and then it stops creating lots of manholes that you don't want. So again, I've just got to select this one, press delete on my keypad and it goes away. Using the shift key allows you to select lots of things at the same time. So we got a manhole naming convention, and as I said, they're all listed there and we can rename them. And that's one of the things for those of you who are learning this and have a background in microdrainage, you will know that microdrainage has that very prescriptive, nailed down numbering system. You know, the first pipe has to be 0.000, then we go to 0.001, bring in a second branch, that's 2000, etc., etc. The thing about InfoDrainage is that none of those restrictions exist at all. We have total freedom to connect things up and to name things in any order we like. You'll know in MicroDrainage there is those offline controls if you want to spill somewhere else. We don't have to worry about anything like that in InfoDrainage. Just connect stuff up where you want it to go and the water will flow. We're using a more advanced simulation engine in InfoDrainage. It is different to the one used in MicroDrainage, and that allows us this complete flexibility. So you could have a pond with, I don't know, 6 connections coming in and 4 going out. You can do all of that stuff completely without restriction. The convention is that we work upstream to downstream. So my particular catchment is draining from the northwest to the southeast, and if I was to switch on my surface information, we would see that's generally where the ground will take it. But and that's good practice. When we come to look at graphs, the graphs would simply be graphing a negative flow if it was flowing in the opposite direction to which we've named it. So the convention is that you start at the top and work down to create your models, but you have total flexibility about how it's connected and how stuff is named. Okay, so we've got our junctions in now. Next job is to put the pipes in. And it's a very similar process. Just go to the connections, drag out the thing that you want to create, left click and drag. You'll see the cursor changes to this sort of crosshairs type thing. Release it on the first one and then drag it to the second one. And when you get to the second one, it does it like that. I'm going to zoom in a bit and again, click on where you want it to start, click on where you want it to finish, and it creates the next pipe. Just keep going down like that. Obviously, if a lot of people will be creating this stuff in Civil 3D, CAD, and then importing it, so you wouldn't have to go through this process. But whether you create it in Civil 3D and then import it, or whether you create it directly in InfoDrainage, the outcome should be the same. We're going to have a series of manholes and a series of pipes. Okay, so I've created my last pipe. They're all connected up now. Good practice, I go back to the select tool to stop me creating any more. Okay, so that's 2 of our building blocks in, our what I call our points, our manholes, and our lines, our connections to bring it all together. At this stage, I'm going to create the 3rd of the building blocks. I'm going to create these areas. Now, what we would do in reality is it would be some skill and judgment from the hydraulic modelers. But what you're essentially trying to do is to say, okay, if rainfall lands in this area, anywhere within this polygon, I assume that it's going to drain to this manhole. So that's the judgment that you're making. InfoDrainage can't help you with that. That's purely your assessment to make, to say, I think this area is going to drain to this manhole. Okay, and that's what we're going to do. We're now going to connect up the inflows to the manholes to which they apply. So I've got a variety of choices here: base flows, catchment area, green roofs or hydrographs. I'm going to start with the catchment areas. So again, the process is left click, drag it roughly where you want it to be, and then this time you'll see the icon changes to this sort of polygon creation tool. Now it doesn't matter where you start or which direction you go in. You can go clockwise or anti-clockwise, but click on the points. So there's a point there. There's also a point halfway along this line here, which it should snap to. So it's just left click to snap. There's a little one just there as well. There's one in that corner and there's one there. Now when you get to the last point, is it right click? Yes, it's right click and it then creates the catchment. Okay. And then we just carry on like that. So put the second one in. I'm going to start here in this top left. Again, it doesn't matter clockwise, anti-clockwise. There's another point there, one down, bottom right, bottom left, one there, and then right click to finish. Okay. I've got a confession to make. As I was creating these catchments, I got kind of progressively more bored of putting in intermediate vertices. So on the third one, there's just one intermediate vertices there in the middle there. And then we go that one, that one, that one, right click to close. And then by the time we got down here, I was just doing 4 points. So again, put the catchment. The convention is that we've got this icon which represents the catchment area. And you'll see there's a little dotted line to show you which manhole it's assigned to. So the convention is that you put the icon somewhere within the catchment polygon and then left click, 3, 4, and right click to finish. I'll just keep going like that. I can zoom in and out as I go along, but put it somewhere in the middle. 1, 2, 3, 4, and right click to close. Just keep going down like that. 1, 2, 3, 4, and then okay, so on this last one, and then go back to the select tool. So on this last one, I've made a mistake. I put in an extra vertice that I didn't want. So all we would do is select the catchment and then just drag that vertice around. So if we ever need to, reshape or resize a catchment, that's what you do. Just click on it, and then you can move these vertex points around. I think we can add or edit vertices, so we can just do it from there. I think, yeah, if you just click delete on them, you can remove them or just put them in, and you'll get an extra vertice there. The other thing that we can do from here, again, go back to the select tool, or I'm going to carry on editing, moving these vertices around. But the other thing you can do is reconnect the inflow. So if I don't want this this particular catchment to drain to this manhole, I'll just reconnect the inflow, and then it's asking me which manhole do I want to connect to. So I'm happy with it. Now we get this thing here, inlet, new inlet 1. It's all a bit confusing. We're going to deal with this a lot more in subsequent exercises. But if you have this now, just press on inlet and it'll connect it up. Okay, and always back to the select tool. Okay. Now this is probably a good place to save our work. We've got the basic information in there. So if you go File and Save As, again, we're not going to be using a template yet. We're just going to save it as an ordinary file. So do a File and Save As, and it's going to go into our Save Work Here directory, and it's going to be called Exercise 2, or whatever you want to call it. Okay, and save it there. Okay, so I've got a very basic model here. I've got no storage structures, no SuDS features in there yet, but I have got the basic 3 basic building blocks: manholes, pipes, and catchment areas. Okay, so perhaps the next thing we want to do is to look in further detail at this data. So if you zoom into any manhole, and then make sure you got the select tool, current, and then double click on it, double left click, and it should bring up its properties. So we can see, for example, we know exactly where it is. It's eastings and northings. We've got our cover level here. Now this is being pulled from the surface information that we loaded up in exercise 1. It's got a depth of 0, so there's no depth to this manhole at all. So it'd be no good to try and analyze it yet or do anything with it at the moment, because the manhole is essentially just exists at the surface. But we've got a diameter of it, 1.2 meters. We can edit that if we like. We can also look at the what's coming into it. So what's coming in from the surface. We've got one inflow connected, and we can see what's going out of it as well. So we've got the pipe coming out of it, and we'll do a lot more with this as we go through these exercises. Okay, but the basic philosophy is click on something and it'll bring up its properties. When it comes to pipes, if you double click on a pipe, now for this, it brings up a table of all pipes, and this is something which may change in the future. So if you're running this in a later version, it may just bring up the one pipe, but at the moment it brings up all pipes in a table. So we can see we've got the 7 pipes there. Again, we could rename them if we wanted to, but it brings up basic information like the length of the pipe, the upstream and downstream cover levels, the upstream and downstream invert levels, which again make no sense at the moment because we haven't designed this system yet at all. We get that information, and of course the same principle applies to the catchment areas. Bring up a catchment area and it gives you all the relevant information about a catchment area. Okay. Now there's another, so that's the first way of looking at information, is just to double click on something and it will bring up its characteristics. The next way of looking at things is to look at the data in tables. So if we go into the build tool, build menu item, and then look at tables. Now I'll be honest, I think these tables will probably change in the future. So again, you may be looking at something slightly different from what I've got here. They are, I would say, too complicated at the moment. They're perhaps over-designed. But the way they work is that across the top, you've got the 4 tabs corresponding to the 4 basic building blocks of types of information that we want to create. And from there, you can then choose what information you want to see in the table and how you want that table to appear. So I'm going to look at the inflows, and I'm going to look at my inflow tab. Now it's going to bring up, once you click on there, it's going to start putting some information here. And again, it remembers what your last selection was. So it's quite possible that the information you're looking at is going to be different from the information that I have on the screen. But over here on the left, you get to choose which information appears in these tables. So if you don't want area to appear, obviously untick that box. Now there's one thing in particular that I'd like you to change, and one thing that we need to edit about this model, and it's located under time of concentration, and then it's percentage impervious. So regardless of what other items you have ticked here, can you expand this until you can see percentage impervious and get that percentage impervious column appearing? Now, what percentage impervious gives us is we've digitized this catchment boundary, or any catchment boundary, and it's saying what proportion of this catchment is impervious to rainfall. In other words, rainfall landing on it is going to run off over land and enter our manhole. So this is extremely important. It's fundamental to calculating how much rainfall is going to make it into our manholes, and therefore how big our pipes need to be to receive that rainfall. And we need to edit this number. Now I'll explain the basis of this. If we were together in person, at this point I would be moving to a whiteboard and showing how that works. Because this is a recording, I'm going to do this virtually, but imagine this is a whiteboard. So throughout this model build process, first thing we did was we put in the manholes. I've got a manhole there, and we connected it up using the pipes. Now, as I said, our next job was using our skill and judgment as hydraulic modelers, our job was to estimate what area would actually drain to that manhole. Okay, so that's our area. And my assessment is that this area will drain to this manhole. Now within that area, there's going to be a land usage. And remember, we are designing typically new housing developments, industrial estates, commercial developments, that sort of thing. But let's say this is a fairly typical urban area. So it's likely that we're going to have some sort of road flowing down here. Sorry, driving down there. Maybe some sort of junction here. This manhole might be at the junction of two roads, like that. Apologies for my terrible drawing. So we've got a road like that. So the red area is our road. And then here we may have some houses. Okay, over here we may have a parade of shops or a church or a school or whatever it is, but we're going to have some sort of built up areas. Now typically catchments are divided into three separate groups. We've got firstly the roads. Now in a typical urban environment, roads would constitute about 30% of the area. Imagine if you're designing a runway or something like that, a big runway, then it could be 100% roads. But in a typical urban environment, it's going to be about 30%. Then we've got the roofed areas. And again, if you're designing a big industrial warehouse or something like that, maybe the entire catchment is a roofed area. But again, in a typical suburban new development environment, again, it's going to be about 30%. And the remaining area, what we describe as the permeable area, and that's for all the back gardens, grass verges, open undeveloped land, all that kind of stuff, which is not covered by roads and roofs. In other words, not sort of concreted or tarmacked or slated over. That's going to be about 40%. So this assessment is extremely important because these two numbers together give us what we describe as the percentage impervious. Some people reduce it to what they call PIMP, percentage impervious, P-I-M-P. And as I said, depending on what you're designing, this could be up to 100% if it's totally tarmacked or concreted over, but typically it's going to be somewhere in the region 60, maybe a bit more, but that's fairly typical. Now, for better or worse, InfoDrainage only considers flow from these impermeable areas, and you get nothing from the permeable areas. So making this assessment is extremely important, and you can do it. Some people do it extremely simplistically, like I've done, make some sort of blanket assumption for the entire catchment. Others would have these polygons digitized in a GIS, which is a great way to do it. And if you do have those catchment polygons digitized, they can be imported, and it's an exercise that we're going to be doing later on, which looks at how these catchment boundaries are digitized. But also outside of InfoDrainage, some GIS packages have the capabilities of doing this. You can digitize your polygons and you say, right, I want this polygon to be impervious and this one as well and this one. And then there are GIS packages which will automatically do that assessment of what proportion of this blue area is covered by the red polygons. So you would get a much more accurate calculation of PIMP rather than this estimation of what I've been doing. But whichever way you do it, however much time you choose to spend on it and the accuracy that you put on it, it is important that this assessment is done. Once that assessment is done, it is then put into our InfoDrainage model by populating this column. And one of the reasonable facilities that InfoDrainage has is that if you select a column, put in the value that you want, press equals, it changes that column. So tables are great for editing large amounts of data or large, changing columns of data at one time. So use it throughout your model build process, but in particular, you will always, unless you're designing, a fully 100% impervious car park or runway or something like that, large warehouse structure that's completely roofed. But in the majority of cases, you're going to need to do this assessment and change this percentage impervious value. Okay. When you've done that, press OK, and those values will then be remembered. So that's the basic principles, is that we create something, we then double click on it to then get access to its characteristics, or we can open all of those characteristics in tables. And of course, if we change something in one view, so we change something in the properties, it automatically updates all the other views like we would hope and expect it would. Now the next thing I want to address is just the look of this model at the moment. I have to say it just looks a bit busy. There's too much going on. These labels are too big and they're taking up too much area. So the next exercise, short exercise, is to talk about the annotation. So if you're following the notes, we're on section 2.2 now. We're just going to talk briefly about annotation. And the way it works is that we can click on any one of our basic building blocks. I'm going to choose the junctions, and then we can go into the display settings. Now we already use the display settings to look at the surface information, and we can edit that there. But now we're coming and looking at how the information appears in the plan view. So we've got now text height and the icon height, and I think it's all a bit big at the moment, so I'm going to change the text height down to 4 and the icon heights down to 10, and it just looks all a bit more manageable then. And again, just like the surface information, we can choose how transparent or opaque it is from there. Okay. Okay, and I'm not following the notes exactly here, but if we were to look at the inflows, for example, we can choose whether the entire inflow boundary is switched off or just the labels are switched off. So you have total control over exactly how these things appear. You can change the colors, whatever you need. Okay, so get a display that you're happy with. If we want to turn off something entirely, easiest way is just to turn it off in the tree view. And now we're looking at the background GIS map, so we could turn that off as well, so we don't see it at all. Okay, so you have total control over how stuff is displayed and what you see. Just to match the notes there at the end of section 2.2, I'm going to turn on the surface color fill again, so we can now see this in the background. Okay. And the next section, section 2.3, is looking at flow paths and the profile view. Now this is extremely important, and it is a fundamental part of the model build process. So we use flow paths for two reasons. One is to check the connectivity to make sure that stuff is actually connected up, and the second is to create the profile view or long section view. Now connectivity is extremely important because, as I said, we have this complete flexibility. We can connect stuff up in any order that we like. However, because of that, there's no guarantee that things are connected. You know, in MicroDrainage, if you deleted a pipe, it would renumber the entire system, so it's very obvious. Here it's much less obvious, so we have to use these flow paths to check that stuff is actually connected up. And the way that you do that is, starting from the tree view, right-click on a flow path and add in a new flow path. And you'll see it goes away, and the icon now changes to this square box. And what we need to do is to pick the first junction in the system. The icon should turn green, and as you move down the system, all subsequent junctions should turn green. In fact, you can go straight to the bottom here. As long as the last one turns green, if you then click on it, it then connects them up. So as I said, extremely important, because just because things appear to be connected, even if you snap them together, it may not have actually made that hydraulic connection. So extremely useful to check that it has actually connected everything up. Just like everything else in the tree view, flow paths can be renamed. So right click on it and rename it if necessary. And I'm just going to call it flow 1 for the sake of argument. So as I said, flow paths, just the act of creating them is an extremely important part of the model build process to ensure that we've got the right connectivity. However, they have a second advantage of they then allow us to create these profile or long section views. So once you've created a flow path, right click on it and show profile, and it then brings up that profile view. So we've got the profile at the top here, and we've got some information about that profile down at the bottom here. And you can, I believe, change what appears in this list. You can edit that list. You can also zoom in and out here to see what's going on. So we've got the table at the bottom and the long section or profile view itself at the top here. Now what we've got at the moment is we haven't begun to start designing these pipes. So we can see the green, the top of the green, this is being read from the surface information, and then the pipes are currently being laid on the surface. So we haven't begun to design them or put them below the ground yet. So the default assumption is obviously ridiculous that these pipes exist on the catchment surface. The pink line, this is how deep the pipes are going to be put once they're designed. So this is a fixed distance below the surface information. So once we've designed these pipes, it'll be a good visual check to make sure they're far enough below the ground. And I'll be talking more about that in section 3, the pipe design process. But that's the end of section 2 now. We've built our model and we've viewed the data and annotated the data associated with it. So the final thing is now to save the data. So file and save, and it goes away and saves the information. In fact, I'm just going to close the profile view and then save again, just from the top there. And that's the end of section 2.